Ready for the last video of the year? This one is wrapping up our radical unit. It is solving radical equations. So we did addition and subtraction, multiplication and division, and then how to solve them always comes after that. So a radical equation now is what we will have in this section, and that means that it just has an equal sign. Everything we've been doing before has just been a radical expression, like the square root of 20. We don't have the square root of 20 equals something, we just had the square root of 20. So to solve a radical equation algebraically, it is necessary to use the inverse of taking a square root. For non-negative numbers, squaring and taking the square root are inverse operations, just like multiplication and division and addition and subtraction. So taking the square root of something squared, like this right here, crosses them off. It's the inverse operation. Or you can square a square root, and the same thing happens. Those get crossed off, and we are just left with x. We've already done some of this kind, so now we're going to do the other side of that equation. So let's start off with some ridiculously easy ones. Square root of what gives us 6? Hopefully you can just think through that problem, but if you need to do some math, we want to do the opposite of squaring. We want to do the opposite of square rooting, so we're going to square both sides. That leaves me with just plain old x, and 6 squared gives me 36. So here's one with a little more work to it, but not too much. We need to get x by itself. So right now there's a 27 being multiplied and the square root of it's being taken. So we need to undo the square root first, so square both sides. 9 squared gives me 81, which equals 27x. And then just like any other time we've solved equations, divide both sides by 27, and we'll get the x equals 3. Pretty simple. They don't really get much harder than that. Sometimes you need to do a little more work before squaring something, and then other times once you square something you have to do a little more work. So let's do A and B, and then you guys can try C on your own. So before I can square both sides here, because if I squared both sides, I'd square all of that, and then I'd have to double distribute. No thanks to that. So instead, I can get the square root of x by itself. So let's add 2 to both sides. So now I have the square root of x equals 3. So if we want to figure out what x is, we could think about it. Or algebraically, we want to undo that square root. So square both sides, and we get 9. Now B is a little different because the 7 is also underneath the square root. So that means I can't just subtract 7 right away because it's being square rooted. So before I do anything else with this, I need to get rid of the square root by squaring both sides. So that gives us x plus 7 has to equal 25. And think about that for a second. It totally makes sense. Whatever was under here, I need to take the square root of, and I'm just going to be left with 5. So we want whatever's under there to be 25, so that when we take the square root of it, we just get 5. So now to get x alone, subtract 7 from both sides, doing a whole bunch of inverses, and we are left with x equals 18. And the awesome thing about solving anything at any time is you can always check your answer. If you plug 9 back into this first equation and plug 18 into the second one, you should make your equation true. And that's how you know you're doing it correctly. C has a lot of things going on with it. So pause the video, try it on your own, and then compare your answer with mine. So after all that work, you should have gotten that x equals 3. And again, you can plug this back in. 3 times 3 will give us 9 here. If you add 7 to it, we get 16. Take the square root of that, we get 4. Subtract 1, we end up with 3. So our answer works. We know that we are correct, and we can move on to the next problem. So these ones, we're going to have multiplication and division hanging out with our radicals, and we need to undo those. So there's always more than one way to solve a problem, and in this case it's important to point out the 2 ways because it can make your life a little easier depending on what the problem is that they give you. So when using multiplication or division, it's usually possible to solve radical equations with 2 methods. Either you could square both sides first to get rid of the square root, or you could multiply or divide both sides first. The reason why we don't have two options back here is because, like I had said before, if I draw parentheses around here and squared this, because there's addition or subtraction in here, I'd have to do double distribution. But for something that is multiplication or division, we wouldn't need to do that. If I squared this side here, I would have 2 squared and then the square root of x squared. No double distribution, we would just get 4x and we can move on with the problem. So that only works with multiplication. So we could have definitely done it that way. Or we could do it the other way. So what I see when I look at this problem is a 2 being multiplied by the square root of x. So I want to undo that multiplication before I undo my square rooting. And then if I square both sides, I end up with x equals 121. So just like all of the other things, we could plug this back in and check it. Try both of these on your own, and then check your answers with mine when you get done with them. Alright, so the very first one you should have ended up with 64. I like to get the square root by itself first, so again, I did this method. No need for a calculator. I can square 8 in my head, little numbers. Or you could square everything first, and you would have been left with this 4 equals x over 16. Still going to give us the same answer, but some people might not know 16 times 4 off the top of your head, where everyone should know 8 squared off the top of their head. And then the second one, you should end up with a nice pretty 100. And again, it doesn't matter which way that you do this. I again got the square root by itself first. I multiplied by 5 on both sides so that crossed off. And then I divided both sides by 2, so I finally had the square root by itself, and then squared both sides. But if you do it the other way, you're going to get 4x over 25 equals 16. And I multiplied by the reciprocal, and again, 16 times 25 isn't something most people tend to know off their heads. And then if you divide it by 4, you will still end up with 100. Alright, now is where it gets a little difficult. We have square roots on both sides of the equation. We need to get rid of the square roots. We cannot do anything with those x's that are underneath the square roots until we have gotten rid of them. So if we were to just look at the left side and I had a square root on something, just like everything that I have done up to this point, I would want to square to undo the square root. And then remember, whatever you do to one side, we got to do to the other. So on this left side, the square and the square root cross each other off, and I'm left with 3x plus 2. And that equals square root and the square cross each other off, so I get x plus 6. So now we can just solve this like any other equation. Move all your x's to one side, so I get 2x plus 2 equals 6. Move the numbers over, and we get the x is 4. So I know these look scary, but they're really not that bad, because when you square both sides here, all we do is just cross off the square roots, and then we're done, and then we can solve it like a plain old equation. Now b can be done a couple different ways. If you take a look at this equation, how it is right now, and say, all right, let's square both sides. This side we get 0, super easy to do. But on this left side here, because there's subtraction in the middle of this term and this term, we would have to double distribute. I don't want to double distribute with radicals, so let's think about an easier way to do this problem. Because it equals 0 on the right side, all I really need to do is move one of these guys over. So let's move over the square root of 6. So now what this says is that the square root of 2x minus 5 equals the square root of 6. And if I go to solve this, all I have to do is square both sides, and I am left with a super easy peasy equation that I can almost do in my head. So when you see a problem like B, don't be tempted to just start squaring both sides. See if you can make your life a little easier, because then there's no double distribution involved. All we gotta do is add 5 to both sides. So we get 2x equals 11. And if we divide both sides by 2, we end up with 11 halves, or 5.5. Remember, we can still check this. Plug it back into the original equation and see if we get 0 out. Alright, so I was kidding about those ones being hard, but these next ones are actually a little more difficult. And it's just because we have to remember what to do with quadratic equations. So if we square both sides of an equation to solve it, sometimes it results in a squared variable. So this one right here, if I wanted to get the square root by itself, I'd end up with an x squared term. And remember, that makes something quadratic. So that means I can't do inverse operations to solve it. I have a couple options. We could break out the quadratic formula. We could factor it out if it's factorable. We could use completing the square, or the square root method if it applies. And in this case, when we rearrange everything so that it equals 0, we end up with something that's super easy to factor. So I would always suggest factoring before the quadratic formula, but some of the things I give you, you might not be able to factor. So remember, if it's quadratic, you have to make it equal to 0 to use the zero product property. So once it's equal to 0, I found two numbers. They added to make 1, and they multiplied to make -6. And then we use those two numbers to make our factors. And then we set both of them equal to 0. So x plus 3 equals 0, and x minus 2 equals 0. So here's my solutions. X could be 2, or it could be -3. But let's think about what we did here. Whenever we solve a quadratic, we end up finding both square roots of a number, which can lead to a problem. And what I mean by both square roots is, remember when we did like the square root of 9, we said you could really get out two answers, plus or minus 3, because if you take positive 3 and square it, you get 9. But also if you take -3 and square it, you get 9. This is an issue now, though, because we're going to be going the other way around. So if I take the square root of a negative, can't happen. It doesn't work. So when we solve these, we might end up with something that we called extraneous solutions. Hopefully you remember that from the rational part. But we always need to take our answers and plug them back in. So 2 and -3. Think about back up in this original equation. I could plug in 2. So 6 minus 2, and I want to know, does that equal 2? And in this case, we get the square root of 4, definitely equals 2. But then if we try plugging in -3, we're going to get 6 minus a -3, and I want to know if that equals a -3. So if I add here, I get the square root of 9, which does not equal -3. It equals 3, but not -3. So you always need to check your answers. Sometimes you will have extraneous solutions and sometimes you won't, but you always need to check, and then you cross off the ones that are extraneous. So if you were going to put your answer down for this problem here, or if it was like a multiple choice thing, both of these answers are not correct. Only the 2 is one that works in our equation. The other one is close to working in our equation and follows a pattern that is represented in our equation, but it does not make our equation true. So let's do one together, and then you guys can try 2 on your own. Let's do B together. So if I want to get x by itself, there's some x's underneath the square root. So let's square both sides. So I get an x squared on the left equals -3x minus 2. Now I see that it's quadratic, so that means I need to move everything over to one side and make the other side equal to 0. So if I move the 3x's over, they become positive. My 2 becomes positive. and equals 0. So now let's think through factoring before we do quadratic formula. Are there two numbers that add to make 3 and multiply to make 2? And there are, 2 and 1. So that means I can split this up into x plus 1 times x plus 2. And then remember the zero product property says that if you have two things multiplied together and they equal 0, you can split them up and set them both equal to 0. And if we solve this, we end up with our solutions being -1 and -2. Now before we box these up and say that we're done, we need to test them out in our original equation. So if I plug them back up into my original equation, I want to know, does -1 equal the square root of -3 times -1 minus 2? First thing that should give this away is I'm asking for the square root of something to equal a negative number. It's not going to happen. We can test this out and go a little further. We'd end up with 3 minus 2, which is 1, and the square root of 1 is 1, but it's definitely not -1. So that means -1 cannot be one of my solutions. And then if we go and we plug in -2, we're going to end up in the same boat. I want to know if -2 is equal to some junk underneath the square root. Doesn't matter what that junk is, we cannot take the square root of something and have it equal a negative number. So -2 doesn't work either. When this happens, when both of your choices do not work, we have no solution. There is not a single number on planet Earth that will make that equation true. Right now, pause the video and see if you can get A and C correct. So, problem A, you should have found no solution that works. Some point in this equation, right here where I've drawn all the arrows, you end up with the square root of something equals a negative number. Again, that can't happen. So if we keep on going with this, you'll square both sides, you'll get positive 25, which is nice and pretty, and then you'll end up with 5 as your answer. But when you plug that back in, you get 11 plus 5 equals 6 instead of 11 minus 5, and that is not true. So that means 5 doesn't work, that there's no numbers on this planet that will make that work. And then C, similar to that, we had to square both sides. Don't forget that you needed to double distribute here. You can't just give me x squared minus 4 there. It's totally different. So you end up with x squared minus 4x plus 4 on the left side. You need to subtract x from both sides to make it equal 0. And then I could factor it. I found two answers that work in the factored form, 1 and 4. And when I checked 1 out, I ended up with -1 equals 1. And since that's not true, we cannot include 1 in our final answer. But 4 works. So we have one solution that works. There's only one possibility. Make sure you put a mark next to anything you have questions about, and I can answer them in class tomorrow. And you are not only done with this video, but all of 8th grade math videos and 8th grade algebra. Good job.